This is question 10 from tutorial sheet 5 from Engineering Dynamics. This type of question is similar to sort we'd ask in an assessment. There's a linear momentum part of the question, and then we're asking you to use that information you've obtained to do a linear motion calculation that we would have looked at back in learning outcome 2. So let's see what we're being asked here. We're told two railway wagons, A and B, are moving on a level track in the same direction, and we're given the mass and the velocity for each one. So it's always helpful to draw a simple diagram, I mean a very simple diagram indicating what's happening here. So here we have A, here we have B, and they're moving in the same direction. Well, they're going to come together. A is going to be moving into B and coupling up here. So we've got A weighs 3 tons, is traveling at 5 meters per second, and B weighs 7 tons and is moving at 4 meters per second. So A is going to catch up with B, and they're going to couple together and continue traveling. So what we're going to have after this is we're going to have two of them together, A and B. They'll have a combined mass of 10 tons, and we're trying to find out what velocity that's moving at there. So sometimes a picture can be helpful to our understanding what's going on in the question. So let's put this into our formula, and remember, for tons we'll multiply by 1,000 to put this into kilograms. So it'll be 3,000, 7,000. I'll quickly write this in. 7,000 kilograms and 10,000 kilograms. So we have used our formula M1U1 plus M2U2. We can skip ahead on the right side because we can write M1 plus M2 times Vf, our final velocity for the two, because we know they're going to have the same velocity, so we can lump these two together. Just taking what we have our standard formula and tidying up a bit before we go on. So we've got 3,000 times 5 for wagon A, we have 7,000 times 4 for wagon B, and then we've got 10,000, which is our combined mass, times Vf, which we don't know. So let's tidy this up a bit. 15,000 plus 28,000 equals 10,000 Vf. So Vf is equal to 43,000, which is the left-hand side added together, divided by 10,000. And as you can see, that's going to be 4.3 meters per second. So that's the final velocity. And as a bit of a common sense check, it was going to be somewhere between 4 and 5. If one of them is moving at 4 and one of them is moving at 5, and they move off in the same direction, the resultant velocity is going to be somewhere in between there. But we need to do our calculation to find out where. So that's part A. Part B has got nothing to do with linear momentum. We are relying on something we looked at earlier in the course for this. So we are asked to find the deceleration rate so the deceleration rate is 0.3 meters per second squared. So A is minus 0.3 meters per second squared because of deceleration, and we want to find the time that's taken for them to reach rest. So in this case, the initial velocity is going to be what we worked out in the first part. The final velocity is going to be 0 because we know they come to rest, and we can use a version of this formula for motion V equals U plus AT. And in particular, we want to rearrange it for T. So T is equal to V minus U divided by A. So V is 0, U is 4.3, A is minus 0.3. So if you divide minus 4.3 by minus 0.3, we're left with a positive number because a negative divided by a negative is positive. And that works out at 14.33 seconds. So it's just what we did back in learning outcome 2. We're just getting the information for this question from a linear momentum problem in part A, and that solves question 10 from the tutorial sheet.